Because it was the question that got posed to me yesterday, we're going to think about a deck of cards. Okay, now before I set you loose on it, there's one important thing that you need to see in a question. Because at the moment, this question cannot be done by binomial probability, the way that we've just done it. Okay, there's something missing. Okay, think about it. I told you there were 3 different kinds of things you needed to look for to know when to use binomial probability. Is it multi-stage? Yes? Yes it is. Okay. Can you think of the question, can you phrase it in terms of 2 outcomes? In this case you can. Clubs, not clubs. Okay? But there are some words you're going to need to look for to know that every stage as you go along, when you pick your 5 cards, they have to be identical. What words would you look for with replacement? If you do not see this, that's your big flashing red sign to say, sorry, tough luck, you're just going to have to draw a probability tree, okay? But when you see this, it's like your sort of green ticket that you can just go to this, right? So, if you want, you can draw yourself a diagram, though, like I said, it's going to get hard very fast, okay? I'll leave this here so you can use this to help you think. As we said before, we want to break up an event into 2 different outcomes, and we already identified, at least in this set of questions, you're either going clubs or not clubs, right? So the probability of just a club for one of those stages, right, is how many clubs are there in a pack? 13 out of 52, or alternatively you can say, well, there are 4 suits, right? So the probability of club is a quarter, which means the probability of its complement is 3/4. Okay, so these are going to be our building blocks, right? Let's start off. Part A, if I want 2 clubs, then that probability is, well, I think about the number of ways, right? This is how I start. And I've got 5 to choose from, but I only want 2 of them to be clubs, okay? And so now I think about, well, what will the probability of the stages be, right? Well, this is of a club, and I've got 2 of them, so it's squared. Right? And then the other 3 remaining cards will be not clubs. There you go. That's it. Whatever that works out to be. Okay? Part B I'm going to work out in exactly the same way. There are 5 to choose from and I want one of them to be a club. Right? So there are 5 ways to choose just one club. And you could, because this is a simple case, you can actually write that out. Look, it'd be, club and not club, not club, not club, not club. And then not club, get a club second. You can write these out quite easily just by pushing the club across. You get the idea. Okay, it's just so you can get in your head, I see what's happening. And then you think about, oops, that's not equals. I'm going to multiply by the probability of getting that 1 club, which is wherever it's going to be, it's just going to be a quarter, and then 3/4. Okay, fine. And when you get to part C, right? When you see things like this is, well, it's as close as it gets to a big red flashing light to say, okay, I don't want to think of all the different ways. There's a better way to think about this. How can we approach it? It's a complement, isn't it? The probability of getting at least 1 club. Well, what's the only way to not get at least 1 club? You get no clubs, right? So this is the probability, this is the complement of 0 clubs, right? So then how do I work this out? How do complements work again? So, wait, slow down. Before I get to the numbers, right? In terms of probability, it's like this. That's what the complement means for us. Okay, that's an important line for a marker to look for. Okay, so now I can go to numbers. Okay, how do I get no clubs? Well, I've got 5 to choose from, but I don't want any of them, right? When I think about how many times I need to consider this probability, the answer is no times because I don't have any of those. And then the remainder, they're all going to be not clubs. Okay? Now when you get to the last one, there's kind of not really much way to get around this. Okay? A complement doesn't neatly divide it into something that's hard to work out and something's easy to work out. You've just got cases, right? So how many different possibilities are there for getting at least 4 clubs? There's 2. There's 4 clubs. Or 5 clubs, right? Now, I write it out like this so that for me in my head, it's clear that I add these and I do not multiply. Why do I add and not multiply? Because these can't possibly be happening simultaneously. If you got 9 cards for poker, you'd win every time, right? So these are separate cases, that's why you add them, yes? And then of course you work these out the same way that you did before. 5 choose 4, 4 of those, 1 of those, and then 5 choose 5. Cool, no problem. Right. So therefore, you're starting to get a feel for it now. Let's generalize. Now, when they talk about these, they say, whatever event, you know how we divide it into 2? Okay. Whichever event you're interested in, they call that a success. Okay. So here's the general case. If what you're interested in is some number of successes, two successes, 1 success, 4 or more successes, okay? We'll call that number K, how many successes you're after. The probability of getting K successes out of, well, how many things are here, right? This represents the number of stages in our multi-stage event, right? So you've got successes out of stages, okay? So in this case, there would have been 5 stages, right? Well, there are going to be 3 components, First, you're going to work out, well, how many arrangements are there, how many combinations are there that will give me exactly K successes, right? So you have N choose K, right? That's what it is every time. It was always 5 choose something. 5 choose something, 5 choose something. You get the idea. N choose K, right? And then you got 2 pieces left. What are the 2 pieces? How did we get them? You got them from, I rubbed it off. You got them from whatever were the 2 terms in your binomial, right? So what they were the probability of a success. Now, that's for a single one, right? Like say a single club. How many of these do I need? What power do I need to raise it to? Answer K, because I'm going to have K successes, right? But then you have to multiply by another probability. What would be a sensible thing to call that? You either call it not success or you could call it failure, I suppose. Probability of a fail. Okay, now how many of those are there? How many times does it fail? Well, there are N in total, and you take away all of the successes of which there are K, which leaves you with N minus K. Right? So this is our generalization for what we've been doing here.